Remember that Ørsted in 1819 discovered that a steady current produces a steady magnetic field, and that connected electricity with magnetism. A little later, Faraday therefore suggested that maybe a steady magnetic field produces a steady current. And he did many experiments to show that. It turned out not to be so. And one way he tried that is as followed. He had here a battery with a switch, and here he had a solenoid. He closes the switch, a current will flow, and that creates a magnetic field in the solenoid. And that magnetic field, maybe it runs like so. Depends on the direction of the current. And so now, he put around this solenoid a loop. Let's call this loop number 2. So it was around the solenoid. And let's call this loop number 1, of which the solenoid is part. Whenever there was a current in number 1, he never managed to see a current in number 2. If there is a current going in number 1, there is a magnetic field. And that magnetic field is seen, of course, by the conductor number 2, by that loop. Never any current. And so he concluded that a steady magnetic field, as produced by the solenoid, circuit 1, does not produce a steady current in number 2. But then one day, he noticed that as he closed the switch, he saw a current in number 2. And when he opened the switch, again he saw a current in number 2. And therefore he now concluded that a changing magnetic field is causing a current. Not a steady magnetic field, but a changing magnetic field. And this was a profound discovery which changed our world, and it contributed largely to the technological revolution of the late 19th and early 20th century. A current, therefore an electric field, can be produced by a changing magnetic field. And that phenomenon is called electromagnetic induction. And that phenomenon runs our economy, as you will see in the next few lectures.